Alright, so let's take care of the homework. So they're not really asking us to justify, but there's going to be a quiz question like this and exam questions like these, so let's just dive in. So 9 over 37 compared to 9 over 41, and for each one I'll just list the strategy. I'm not going to write my reasoning down, but I'll just say it. So this is obviously, right, the numerators are the same. So common numerators, right? And 37ths are larger than 1 over 41. Right? Except on an exam or a quiz, you remember that you need to state how you know that 37ths are larger than 1 over 41 or 41st, however, whatever you want to say, is because when you break a BMU up into 37 equal pieces, those pieces are bigger than if you were to do the same with 41 pieces, breaking up a BMU into 41 pieces, or vice versa. Right, so 12 over 13 compared to 13 over 14. Well, I noticed that they're both 1 away from a whole, so we can use distance to 1 because they're both the same number of measuring units. In this case, they're both 1 measuring unit away from 1 whole. And so we have 1/13th, and we're comparing that with 1/14th, and 1/14th is smaller than 1/13th, which means the distance to 1 is smaller. So this fraction is actually the larger one. 11/13ths compared to 10/13ths, right? Non-comparison. You have more 13ths here than you do there. This would be common denominators, so you're looking at the numerator. Here, 347 over 349 compared to 503 over 505. I'm noticing that they're both the same number of measuring units away from a whole. They're both 2 measuring units away from a whole, so I'm using distance to 1. Let's compare the distances. We got 2 over 349, and we got 2 over 505. Which one is smaller? 2 over 505 is smaller than 2 over 349. So there's a smaller distance to 1. I should probably have mentioned here in question number 2 and here in question number 4 that you're also using common numerators when you compare the distances, right? I should write it up there as well. Because they're both the same number of measuring units away from 1, when you compare their distances, you're always going to end up using common numerators. So now I have 123 over 358, and I have 123 over 309, and I'm going to use common numerators because the numerators are the same. Right, so I'm looking at the size, 309, larger size than 358. I should say that 1 over 309 is larger than 1 over 358. 3/7 compared to 8/15 looks tricky, but we have to go through all of our strategies, right? They don't have common denominators, and I'm not going to use it because there's no instructions that say I can, right? They don't have the same numerator, although I could make the numerators the same. We also have distance to 1, but they're both, right? This is 4 measuring units away from a whole, and this is 7 measuring units away from a whole, so I can't use that strategy. I can only use distance to 1 when both fractions are the same number of measuring units away from a whole. I can only use common numerators when the numerators are the same. So I still have a strategy left, and that's benchmarking, and I could benchmark to a half. When I do that, right, I notice that 1/2 here would be 3.5 over 7, or 3.5/7. Right, but I don't have that. I only have 3/7, so I know that this is less than a half. Right, over here I'm working with 15ths, and I know that half of 15 is 7.5, or 7.5/15. In fact, I have more than that, so I know that 8/15 is larger than 3/7, and I'm going to write benchmarking 1/2. Okay. Here we have 483 over 701, and we have 478 over 722. Looks pretty tricky. So we know that they're both over 1/2, right? So we can't use that as a benchmarking to 1/2. Are they the same number of measuring units away from a whole? I don't think so, but we can find out, right? How many measuring units is this away from a whole? 11 take away 3 is 8. 218 measuring units away from a whole. And this is 244 measuring units away from a whole. So no. So we can't use distance to 1. And on top of that, we cannot use common denominators, and we cannot use common numerators. Technically you can, but let's not do that. So what are some other things that we could do to figure out which one of these fractions are larger? There's one more strategy, and it's greater number, bigger size, right? So I'm looking at the denominators, and I know that 701, the pieces are larger than 722. And I'm also noticing that I have more pieces that are larger than I do here. So there you go. Greater number, bigger size. I have more pieces here, and the pieces are larger. All right, back page. If the 100 stars below represent 6 2/3 fifths, how many stars would represent the BMU? That's loaded. So there are 100 stars here. So let's find out how many. Okay, so let's change this. 6 times 3 is 18 plus 2 is 20. So this is like saying I have 20 copies of 1/3 of a fifth, or 20 copies of 1/15. And I'm a visual person, so I'm gonna draw this out on a number line. This is gonna be a whole, which is 5/5. This is gonna be 2 wholes, which is 10/5. And I need to do the best I can to split my number line into fifths. All right, here's 1/5, 2, 3, 4, 5/5. This will make 6, 7, 8, 9. Oop, that's supposed to be a 5. And now it says 6 2/3 fifths. So here's 6/5. I'm gonna split that into thirds, and 6 2/3 fifths would be here. I'm gonna split the rest of my number line into thirds. Remember that when I split each fifth into thirds, I get 15ths. So this right here is 6 2/3 fifths, or 20 copies of 1/3 of a fifth. So here's the kind of reasoning that's required. If 100 stars, 100 stars is represented by 20 copies of 1/3 of a fifth, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So how can I split 100 stars, right, into groups of 20, how many stars would be in each group? Well, 5 would be, right? Each of these tick marks, or each of these, would be 5 stars. So it'd be like 5, 10, 15, 20, 25, and it's asking me how many stars would represent the BMU. Well, the BMU is right here. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 50. Whoa, did I count right? Let's do that over. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. Is 6 2/3 fifths bigger or smaller than 1/2? Well, 1/2 would be 2.5 fifths, right? So if you have 6 2/3 fifths, it's bigger, right? There are more fifths. In 6 2/3 fifths and 2 fifths, right? That's easy. Is 6 2/3 fifths bigger or smaller than 1? Well, 1 is equal to 5 fifths. So again, 6 2/3 fifths is bigger because there are more fifths. Than in 1, which is just 5 fifths. And last but not least, how many times as big is 6 2/3 fifths compared to 1, right? 1/3 of a fifth. Well, we already said that 6 2/3 fifths is the same thing as 20 copies of 1/3 of a fifth. So it's 20 times as big, because 6 2/3 fifths is equal to 20 copies of 1/3 of a fifth. All right, the end.